That's what happens in this reaction. Now, I don't see yet how this applies to kinetics. Here's how it applies to kinetics. We're going to have more in the container than just that and that. We're going to add a third chemical, not to react with these, but actually the third chemical we call the clock. It's actually thiosulfate ion, sodium thiosulfate, that stuff right there. The thiosulfate, when iodine I2 is made, if there's a presence of thiosulfate, the thiosulfate reacts with the iodine and causes it to reduce back to iodide ion. So this clock is going to prevent iodine from forming or being piled up, and therefore, as long as there's some of this stuff, we don't see any blue. There's no blue. As soon as the clock runs out, love that expression, when the clock runs out, then the iodine has nothing else to react with, and it just builds up and the whole solution turns blue. But it takes time.
Is that how magicians do their trick thing? Because it's like, oh look, move for it, and then it's gonna turn blue like now, and then like it starts moving.
Yes.
Oh.
Yes.
And then they're like, oh, it's gonna turn green.
Wait, how do
Yep.
you know
Other
it's
stuff that just like starts running.
You need to use a stopwatch and time it. Let me show you the reaction. It's great. I love doing this. It never gets old to me. So I have, this is my S208. I'm going to measure it out and then just let it sit for a moment. About 10 milliliters. All right. My I negative, the potassium iodide. Yeah, I'll do it in front of the camera. I'm just measuring everything out right now. I'll measure out my clock, the thiosulfate, S2203.
Otherwise, it just like.
All right. Now, here's what I'm doing. I have a reaction container. There's my reaction container. It's an empty flask. I'm going to add my iodide ion. There's my first reactant. Now, I don't want to add my second reactant because it'll start reacting and building up iodine. Yeah, here I have some starch. The starch is great. It's this thick liquid. Oh, it's good stuff. Anyway, just 1 drop of starch is all you need. If you're feeling wild and crazy, use 2, but you don't need it. So the starch does nothing right now because there's no iodine in there. See that? It's just still clear. So right now I've got the iodide ion, my one reactant, and starch. And I also want to add the clock first. Now the clock's not going to react with anything until there's iodine, I2, being made. And there's not right now. So here comes the clock. Still nothing. Nothing because I haven't added my other reactant. Now when I add the other reactant, these two are going to start reacting with each other, producing that. But as soon as that's made, it reacts with the clock, and it goes back there. And it just keeps doing that, and we keep waiting and waiting and waiting. Check it out. Yeah.
What if some of the nice before it reacts with the clock?
The clock will break it up and cause it to react. In fact, you're going to see a flash of color at the beginning. Watch. See it? But then the thiosulfate does its thing and reacts away the I2. And so we watch, and we have the time. As soon as you add that S208, you start the timer, and you watch, and swirl, and hope, and wish, and wait, hoping that there will be a change in color when the clock runs out. The clock is ticking, so to speak, right now. Don't blink. Don't look away. You'll be sorry.
Look really fast.
Just don't hold your eyes open. Keep watching.
But if it's just one.
Now, if we increase the concentration of the reactants, maybe it'll go faster. We pretty much don't. Looks like the reaction does, though.
Is it okay to drink that?
I was supposed to use 5 milliliters of clock. There it goes. See? Yes. There it is. I was supposed to use 5 milliliters of clock. I was just going fast. I used about 6, and it made a bit of a difference. It does take longer. The more clock you have in there, the more. So that's what our reaction looks like. All right, now I know it's about time to leave. Please don't get up and walk out yet. I want you to see one more thing. We have to run this 4 times.
Oh my.
4 times. Because, now don't get scared and run away. Our data is going to look something like this. For the 4 trials, 2 of the trials you're going to use the exact same amount of reactants, but one's going to be hot and one's going to be at room temperature so that we can get the 2 Ks at the 2 different temperatures and find the activation energy. So we have to do those 2 trials. But then in trials 2, 3, and 4, we're varying concentrations of the reactants. In trial 2 and 3, we're varying the concentration of Ki, holding this one constant. In the trials 2 and 4, we're holding this one constant and varying the concentration of the S2O8. So varying the concentration, we'll see what happens to the rate, and therefore it will give us a differential rate law. It's a great lab. I love doing this thing. Look at it, we have even a change in color too. It went blue and then it goes green. So it's pretty nice.